We are all witnessing a change in the planet's climate. To a large extent, these changes are associated with global warming. Experts believe the increase in carbon dioxide emissions, mainly from the burning of fossil fuels, contributed at least 60% of the warming on Earth observed since 1850. The concentration of carbon dioxide increased by 0.3% per year, and concentration in the atmosphere is 30% higher than before the Industrial Revolution. One of the primary sources of carbon dioxide emission in the atmosphere is the production of cement. Therefore, reducing its product energy intensity and reducing the number of harmful emissions is becoming increasingly important. One way to reduce cement production emissions is to introduce production waste into their composition, including granulated blast furnace slags. The introduction of slags makes it possible to combine a decrease in the proportion of clinker in cement with production waste disposal, because introduction of mineral additives as a rule leads to a decrease of cement activity. A further increase in active mineral additives share reduction waste is achieved through various cement activation methods. One of these methods is the impact on the hardening binder with magnetic fields. In Professor Liulchenko, it is shown that magnetic fields significantly affect the spin dynamics and control the spin multiplicity of radical pairs. Researchers Lapsik, Simic, Afanasyev, Tsira, Anger, Andreeva, and Alexandrova determined that cement is a paramagnetic substance and that cement hardening occurred due to the recombination of paramagnetic centers. Thus, the possibility of the influence of magnetic fields on the binder's hydration process has been proved. Our work, application of sintering dust for the increase of cement durability, was proposed to use finely dispersed magnetized ferromagnetic additives to activate blast furnace cement. As such an additive, we have used fine dust, waste from the metallurgical industry. In the research study of the influence of properties of dusty ferromagnetic additives on the increase of cement activity, the additive's magnetic and dispersed properties on the activation effect were studied. Obtained dependencies of cement strength on magnetization and particle dispersity and the additive's small portion, up to 2%, led to the conclusion that the activation effect is now due to the filler or pozzolanic effect, but due to the effect of magnetic fields. Still, the impact of long-term magnetic fields on the process of cement hydration wasn't considered yet. Therefore, this research set this task to study the changes in cement hydration and structure formation process that appear under long-term magnetic impacts. Studies of the hydration products of ordinary and modified by additive blast furnace cement were carried out to study the processes of hydration and structure formation of cement with pre-magnetized ferromagnetic dust. The research was carried out by analyzing the binder's hydration product by infrared spectrometry, thermogravity, X-ray phase analysis, and electron microscopy. We have studied the original astringent and hydrated samples at 1, 3, 7, 28, and 90 days. Dust of electrostatic precipitators of the sinter production was used as an additive. The additive was introduced in the amount of 2% of the weight of cement. The data obtained from the research made it possible to carry out a quantitative analysis of the kinetics of hydration of the main components of binders and identify the factors affecting structure formation process. The imposition of weak magnetic fields on a binder during grinding and subsequent storage can affect the cement structure defectiveness, significantly affecting its activity. In the early stages, the dynamics of the formation of calcium aluminates significantly affects structure formation. The content of 9-hydrate calcium aluminates in the modified cement stone aged 1 to 28 days is 1.5 to 2 times less than in the controlled sample, and at the age of 90 days, it is 4 times less than in the controlled sample. The research data indicate the intensive formation of ettringite under the influence of ferromagnetic additive in up to 1 day, and determination of this process subsequent periods. In a standard binder, ettringite formation observes up to the age of 3 days. The observed dynamics of the formation of calcium hydroaluminates and calcium hydrosulfate aluminates allow us to conclude that under the influence of the additive magnetic fields, constructing the Gell-ettringite frameworks occurs faster and completed within 1 day. In the subsequent periods, stable 6-water tricalcium aluminate mainly formed. This mechanism excludes destructive processes in the late stages of hydration. The research results showed that the kinetics of alite hydration in the modified binders significantly differs from the usual one. At the age of 1 to 3 days, 13.8 less is hydrated, and at the period of 7 to 90 days, 4-5 times the amount of alite is hydrated. The slowdown in hydration of alite at the age of 1 to 3 days can only be explained by supersaturation of the reaction space with calcium hydroxide and a shift in the chemical reaction of hydration toward the initial components. The intensive hydration of alite causes an increase in calcium hydroxide hydroxide in the period to the first day. The magnetic fields induced by the ferromagnetic additive cannot influence the diffusion rate of the reaction products. Therefore, the diffusion of calcium ions from the reaction zone in the modified binder becomes the limiting factor for alite hydration much faster than usual. Analysis of the result confirmed the accelerated formation of lime in a period of up to 1 day. In the gel made of modified cement, calcium hydroxide content is 20% higher than in control samples during the period. Also, in subsequent period, the alite degree of hydration under the influence of magnetic fields increases. The content of calcium hydroxide in the gel becomes 23% lower than in the original cement at the age of 3 days, by 12% in the period of 7 days and by 9% in the age of 28 days. Such dynamics can be explained by intensifying lime interaction with granulated blast furnace slag. Analysis of the result confirms that the hydration of granulated blast furnace slag intensified under the action of magnetic fields, induced by a ferromagnetic additive. There is an increase in slag hydration degree by 20% in 3 days, 23% at 28 days, and 59% at 90 days. In ordinary cement, after 28 days of hydration, the slag content practically doesn't change. In the same period, the content of slag in the modified binder decreases by 30%. In the period 28-90 days, the content of alite in the modified binder is insignificant and amount to 4-2% of the original. Such content of alite doesn't provide the slag's hydration with a sufficient amount of calcium hydroxide. The slag's intensive hardening process due to the binding of calcium hydroxide previously formed resource. The process reduces the lime content in the modified cement stone of 90 days of age by 65%. The revealed patterns make it possible to explain the greater efficiency of magnetic activation for belite types of cement. A smaller amount of lime released during the hardening of belite makes this process less dependent on diffusion. Therefore, the formation process in belite cement under the influence of magnetic fields should be more stable. The analysis results show that the ferromagnetic additives has an intensifying effect on the process of belite hydration. The content of non-hydrated belite in the modified binder is less than in control at the age of 1 day by 12%, 28 days by 10%, and a period of 90 days by 19%. Infrared spectrometry data confirm a high degree of silicates hydration at all hardening stages. At the age of 3 days, the original silicates in the modified binder are 1.5 times less, at 20 days by 2.5 times, at a period of 90 days by 4 times. The gels offers a rotation with calcium hydroxide and the slowdown in the hydration of alite explain the changes non-monotonicity in silicates hydration rate it up to 7 days. Analysis of the results shows that the ferromagnetic additive changing the kinetic of hydration reaction contributes to increasing the crystallized double-morite content in cement stone by 1.3-1.4 times. The modified binder at the age of 0 to 3 days has a 5-10% more, and in subsequent periods 15-20% less absorbed water. Such a change in the binding domains of water confirms the increase in CSH formation in the initial period and the higher rate of silicate crystallization structure in the subsequent period. Caused by the slag's activity hydration, the cement gel lack of calcium hydroxide contributes to forming a more significant number of 3-layer double-morite, having a lower specific area 2-layer ones and absorbing a smaller amount of water. Accelerating of crystallization of double-morite changes the structure of the cement stone. In pictures, the cement stone structures pull from the control and modified binder. Lamellar blocks of crystallized double-morite dominate the modified cement stone. The structure of the modified cement stone is more homogeneous and finer crystalline. The pictures obtained 8000 magnification confirm a crystalline structure in the modified cement stone and weakly crystallized disordered structure in the control cement stone. A high degree of hydration of the modified binder reduced the proportion of evaporated mixing water, reducing the cement stone overall porosity. The picture shows the surface of a cement stone pulled from a non-active BFC. Numerous microcracks with a length of 50-200 and a thickener of 0.51 are distinguishably on the surface. Microcracks are oriented in different directions and, as a rule, begin micropores. Numerous micropores are 2 to 30 in size. A smaller number of structural defects distinguishing in cement stone made from a modified binder. A small number of pores with a size of 0.5 to 2 and the absence of prodder. The studies show that the introduction of pre-magnetized ferromagnetic dust into blast furnace cement composition has an activating effect of binder hydration. Activation occurs both in the initial and long periods of hardening. Under ferromagnetic activity, the crystallization of silicates in the modified binder is unchanged. It has been established that magnetic fields have an orienting effect on the direction of growth of silicates crystals, which leads to a decrease in the porosity and effectiveness of the cement stone structure. Thank you for your attention.